Okay, good morning children. We are discussing reactions of phenol. This is the part 2. First, halogenation. Suppose when phenol is treated with bromine water, bromine water color is red, and what we get this product 2,4,6 tribromophenol, and this is formed as white precipitate. So immediately we can see in this reaction the red color of bromine water gets discharged. We also get here another side product, that is HBr, that is Now what happens in this reaction? For bromination, the electrophile is Br plus. Bromonium ion is generated, and since there is we know from the regulatory structure there is more electron density at ortho and para position, so there occurs tri-substitution and we get this product as white precipitate. Now interestingly, here the thing is different. Here we get mono substitution we get. So we need to know why with bromine in carbon disulfide solvent, why we get bromination, monobromination. So here there is a role played by the solvent. We know that carbon disulfide the structure is like this. It is a non-polar solvent. It is a non-polar solvent because its dipole moment is 0. It's a non-polar solvent. Whereas this water we know it has this structure, and it is polar. Water is polar. So what happens here is that polar solvent facilitates the formation of ions. Polar solvent facilitates the formation of ions. So in this condition, there will be a lot of Br plus ion in the system. Lot of Br plus ion will be there, and that's why there occurs tri-substitution. Whereas in this case, non-polar solvent does not facilitate so much the formation of bromonium ion. So there is less amount of bromonium ion. So we get here mono substituted product. Now here I'd like to discuss a question here. This question often comes in exam. Suppose distinguish between phenol and benzyl alcohol. Suppose question comes, distinguish between phenol and benzyl alcohol. So we can make use of this bromine water test in order to distinguish them very easily. So what we'll take these two substances and into different test tubes, and in both of them we will add bromine water. It is red in color, and we will see that the test tube containing phenol, their reddish brown color will be discharged and we get a white precipitate. Whereas in case of benzyl alcohol, such thing will not happen, because you see here the ring will not be activated. Such thing will not happen. Moreover, it is not a phenol, it is an alcohol. So such thing will not happen. So in this way we can easily distinguish. Okay, now there are some other reactions of phenol which are very important. One is, next that we are going to do is Riemann-Tiemann reaction. Okay, next we have Riemann-Tiemann reaction. Is a very important reaction of phenol. So you see, what we need here is sodium hydroxide and chloroform, very important. And the second step we have to do acidification, and we get this compound. So what is actually happening is aldehyde group is coming in the ortho position. This group is called formyl. So this reaction can also be known as formylation of phenol. Now we also get here in this case small amount of para product. Maybe in NCERT book it is not written, but we can expect to get a small amount of para product also. So this is minor product and this is major product. Why this is major product? It is because this H here, which is delta plus, and this O, which is delta minus, there is intramolecular hydrogen bonding. Intramolecular hydrogen bonding is there, and that's why this is the major product. It gets stabilization. That's why this is the major product, and such stabilization does not happen here. So this is the minor product. How can you understand this? I'm just telling a little bit about how it is happening. First of all, actually this reaction is this happens with this reaction happens with this phenoxadiene. This phenoxadiene, this is an acid, this is a base, so they will react and form salt. Phenoxadiene will be there, and phenoxadiene you can write here H also. And then what happens is CCl3, one HCl molecule gets removed, minus HCl. So here it becomes CHCl and Cl. So chloroform, one Cl gets removed, this is formed, and then what happens is this Cl gets replaced by OH in this system. There is water. The Cl gets replaced by OH. So Cl gets replaced by OH, and one thing, two OH attached to same carbon is not stable. Two OH or more than two OH attached to same carbon is not stable. So there will be immediately loss of water. There will be loss of water from here. Loss of water, and we will get here C double bond OH. We will get this one, the product, and finally this acidification, as I was telling, acidification H plus, we will get the ultimate product, this one. So this way you can understand how it is happening, but for weaker children this is also not required. You can just remember this one, that will be enough. So Raymer-Temmel reaction is what? Formylation. One thing let me tell you here is that if instead of chloroform here we use CCl4, if instead of CCl3 we use CCl4, other things are there, then we get this product. We get this product, if we use CCl4. And let me tell you the name of this, common name of this product. This is called salicylaldehyde. This is called salicylaldehyde. This is called salicylic acid. This is salicylic acid. So this is about Riemann reaction. And next reaction that we discuss is coal-based reaction. Okay, in coal-based reaction, what it is there is we get the product COH2 at the oxide position. Here actually what is the actual reagent? The actual reagent, that is this sodium phenoxide is involved. First, this reacts with sodium hydroxide to form sodium phenoxide. Then sodium phenoxide is treated with carbon dioxide at 400 Kelvin temperature and in presence of 4 to 7 atmosphere. And then in the second step we have to do acidification. Then we get this product. Actually here with carbon dioxide we actually get this we get, and this on acidification H plus we get this product. So this is coal-based reaction. Here basically we start with this compound. This compound is treated with carbon dioxide at this temperature and this pressure, and on acidification of this, in the second step we get this as a product in coal-based reaction. Next we have reaction with zinc dust. Reaction of phenol with zinc dust. This is a very easy reaction to remember. Phenol plus zinc. Then what happens is we get benzene plus Zn. So this is nothing much to explain here. And another reaction is phenol when it is treated with a strong oxidizing agent, K2Cr2O7 and H2SO4. This mixture is a strong oxidizing agent. Then we get this as a product. Benzoquinone, this is the product that we get. One more thing about phenol, this is a very good test for phenol by which we can identify phenol. This also I should say is ferric chloride test. Ferric chloride test, very important test for phenol. When phenol or derivatives of phenol is treated with neutral ferric chloride, then we get with phenol we get violet coloration. We get violet coloration. So this is a very good test for phenol. And if it is derivative of phenol, the color will vary, but we get coloration in ferric chloride test. And let me tell you, is any compound which has this grouping, this is called enol, double bond and OH. Any compound having this grouping, whether it's aliphatic or aromatic, will respond to this perchlorate test, and that means on treating them with neutral perchloride we get coloration. So I think this much is reaction of phenol. So thank you for watching. Good day.